All right, what's up, boys and girls? Big fan of this problem. Big fan of related rates. It's not easy. The key is to set up an equation that's true, and then we almost always are going to differentiate implicitly because we're usually talking about change in terms of time. Okay, so here we got a 5 meter plank being pulled up the side of a building. Assume that's just kind of like getting through some science stuff, but it says it's pulling the rope up at a rate of 2.25 meters per second. Do you have any idea what that means?
Does that mean that means like numbers wise?
Yes, like notation in calculus.
Is that y?
It's close. Change in y. It's a
Yeah.
rate. So dy dt,
Got it.
the rate of y in terms of time
Okay.
is 0.25 meters per second. Notice that this is a rate, change in y over change in time.
Okay.
So this unit is a rate, meters per second.
Okay.
Okay? Now, how fast is the end of the plank sliding around along the ground? So what do they want us to find? First of all, which way is this thing sliding?
That's sliding left.
Left. Any idea mathematically or calculus wise what that represents?
Negative.
Okay, we want to find dy dt. What's that? No, dy dt. We know dx dt. Oh yeah, find dx dt. Excuse me. Find dx dt. And notice you said that it was negative, and the answer is indeed negative. So very good. So we're trying to solve for dx dt when it's 1.2 meters from the wall. So when x equals 1.2. Okay? So I've got this. You're not going to be able to read this, but now I've got more room to work. So what's the situation? I got to come up with an equation. All I know is that that's a right angle and that this is 5. So we'll call this y. We'll call this x.
X is 1.
And we're just going to say x squared plus y squared equals 5 squared. That's the situation. That's how they're related to each other. Now, how are their rates related? We have to find that out. We can't find out the rates unless we differentiate this with respect to t. Then it will turn in from a length question to a rate question. So what's the derivative of x squared?
2x.
Okay, that's the derivative of x squared. Very good. With respect to x, what's the derivative of that's right. So now we're going to multiply by the differential. I literally asked GPT today. I asked ChatGPT to explain to me why you multiply by the differential. It was a great explanation. I'm finding like this is one of the many good uses for this.
What did it say?
Oh, you have to read it. You should ask it. Okay. Essentially, the differential. Normally, our equations are explicit. Y equals 10x squared. Y is a function of x. Y depends on x. It's an explicit function. Here, this is not an explicit function. So anytime something happens to y, what happens to y affects x. They're like tied together. And that differential accounts for the small change of the x function as it's pertained to the, in this case, the time. Okay? So then what's going to be the next thing here, Jude?
2y dy dt? So the fact that they both have dt on the bottom is the thing.
Yeah, because we're taking the derivative with respect to time. And then what's the derivative of 25?
Sorry, 0.
0. Okay, now, as we stated on our last page, dy dt is 0.25, right?
Yes.
And we're trying to find dx dt. When x equals 1.2.
Yes.
Well, if x equals 1.2, we could find y, correct?
Yes.
Y squared plus 1.2 squared equals 5 squared. Is this 3, 4, 5? I don't think so.
You want the square root of it?
Just sure, yeah. Just give me y.
I guess the easier way to say it would be 20.56, and that's not the square root.
23.56.
Yeah.
What's the square root of that?
4.85386.
Okay.
That's just an easier form.
Yeah, I buy that. So y is radical 23.56.
Yeah.
Okay. So here we go. We're trying to find dx dt. 2x dx dt is negative 2y dy dt. Do you agree?
Yeah.
So dx dt is negative 2y divided by 2x times dy dt. So it's negative y over x. So how do I come up with the answer? Let's see if we get this right. I just canceled the 2's.
Would it not be 2y dx dy dt over 2x? Because you're dividing that whole side by 2x.
That's the same thing that I wrote down. You're just not as good as fractions as me. Okay? So it's negative y over x times dy dt. And we know all these things. So put all these in your calculator from here, please.
Let me see.
I'll pause it. And sure enough, you get dx dt is negative 1.01, and we are talking about meters per second. So what that means is, because that thing's changing speeds the whole time, but once it gets to about right here, it's traveling 1.01 meters per second.